Hey y'all, my name is Abby. I'm a fifth year PhD student at the University of South Carolina under Aaron Meyer-Gutrod, and today I'll be discussing combining my individual movement model with prey models to better understand demographic habitat use patterns. This work is part of a larger project funded by NSF studying the organismal response to climate change, with part 1 being my individual movement model and part 3 being these prey patch models to hopefully inform a life history explicit species distribution model in the future. My individual movement model is a Brownian bridge, and it estimates habitat use between known locations of an individual. I'm using consecutive sightings that are no more than 30 days apart and assuming random movement between those sightings. And instead of simulating that random movement, I use a probability distribution function to calculate the possibility that the whale was in a given space. This relies on time between the sightings and this motion variance parameter, which I've calculated to be around 21.5 kilometers per day. From this model, I can create daily habitat utilization estimates, and this is an example on the right of a whale traveling from the Gulf of St. Lawrence down, seen off of Long Island, and then down to the southeast US. In this model, I use around 45,000 sightings, and that also includes single location sightings, so when a whale wasn't seen 30 days before or after. And the methods of this model are currently in review, so hopefully y'all can get a deeper read of it soon. The prey patch suitability models, daily patch probabilities were estimated using boosted regression trees and Ecomon survey data. We hope to include a ZMP data in the future. The environmental covariates are from Copernicus, and we use a presence patch value with these numbers of individuals, Calanus being determined off of work done by Camille Ross, and then we have Centropoges and Pseudocalanus. Their patch thresholds were determined from the 80th percentile of the Ecomon survey data. I am using patch or no patch values later in this presentation. I am using these optimal thresholds for determining presence, so where the most true positives and true negatives are being accounted for. And my first look at combining these models was to look at monthly estimated presence in each grid cell and comparing that to the patch probability. Also, in each grid cell, I've attributed them to one of these regional areas, which are inspired by the consortium polygons, and then account for some bathymetry changes as well. And this is a lot to look at, but I broke it up by month for each prey type, and what the main takeaways are that there is a high abundance of right whales relates to a high mean monthly patch probability of at least one prey species. So we see the smaller bugs, Centropoges and Pseudocalanus, in the spring months, and then this is whales in Bay of Fundy with a high probability later in the summer. And I wanted to draw attention to this blue, which is the southern Gulf of St. Lawrence, and it is under this red line, which is the optimal threshold for, so this would be like no patch and patch. And this is likely just not captured well by our model since currently it does not have AZMP data. So next we'll get at looking at the individual habitat use with prey probabilities. Here is a movie of the Brownian Bridge movement model of a whale slalom traveling from Cape Cod Bay and then to the Great South Channel and then the southern Gulf of St. Lawrence. And then on the right, we have Calanus finmarchicus daily probability. I coded using those threshold values for patch or no patch just to be a binary, and then multiplied that by my Brownian bridge to see what is left habitat use-wise. And then I could sum it up for those areas. So I broke the demographic states down into females, their calving year starting in the month of November to October, 1 year post-calving, 1 year prior to calving, 2 years prior to calving, non-reproductive adults and juveniles, and then males we have adults and juveniles, and then calves. To better understand this, my first attempt was to make an NMDS plot of just annual habitat use in each area without prey data. And what we see is kind of a shotgun, not great. We would like to see separation in an NMDS plot. What I do see, since it is a subjective art at the moment, is that these areas of high use habitat are far to the left. And then these areas that are more variable year to year in habitat use or have lower abundances are making up the right half of the plot. But overall, this NMDS plot is not super informative, and I'm going to continue to do some digging. Pulled out those high use foraging habitats, and each point is a demographic group's monthly proportion of time spent in suitable habitat. And the first thing I noticed is that time spent in suitable Calanus habitat in Cape Cod Bay is super low, where that is showing our model is not accurately capturing Calanus finmarchicus habitat there, probably due to the dynamics of Cape Cod Bay and as well as low Ecomon survey effort there. So improvement is needed. Then the next thing I noticed was for the decade of 2000s in the Gulf of Maine and Great South Channel, right whales were seen spending more of their time in suitable patch habitat for Calanus finmarchicus, which we know was a good decade for right whales. Then looking at this in general age and sex groups, it looks like across prey species and across decades, the groups spend similar amounts of time in suitable habitat. And what I picked up here was there was a slight increase of habitat spent in the 2000s in Calanus finmarchicus habitat, where they're above the 12.5% compared to the 90s and 2010s. Then looking at just the female groups by decade and prey species, the first thing I noticed is that in the calving year, females are spending more time in suitable habitat across prey species. And the 2 years prior to calving is slightly higher in some of this modeled habitat than the non-reproductive whales are spending or whales that were 1 year prior to calving. I also wanted to look at site loyalty with Cape Cod Bay as a case study. So in 2017, that was the largest number of days estimated of habitat use, where I had over 181 whale days in the CCB. And I wanted to look at who are these whales that are coming into the Cape Cod Bay that year, who are the newcomers. Demographically, there's calves, adult females that are all non-reproductive adult females, juvenile females, adult males, juvenile males, and one adult sex unknown. And I can also ask from my model, where were they in the previous Aprils? And what we see is that there is a lot of time spent in southern New England, which is this pink, the Great South Channel, which is this purple, also the southeast US, in the mid-Atlantic, and sometime in Massachusetts Bay and Gulf of Maine. Then looking at habitat use in 2017 and after, we see that these whales keep spending a lot of time in Cape Cod Bay and return in 2018 and 2019. So there are improvements needed in moving forward with these combination of models. The first being incorporating AZMP data so that we can create a Canis hyperboreus layer is essential. What I need to ask is, just because time is spent in suitable patch habitat, does that mean it's calorically suitable? So maybe ways that investigating this is going to be calving ability at the population level, and then at the individual level incorporating body condition or baleen insights. And do these changes in site fidelity, are they signaling lost or gained habitat? So are whales being attracted with suitable habitat, or are they moving because habitat is poor where they used to frequent? With that, I'd like to say thank you to everyone who participates in the collection, organization, and distribution of this data and identifying right whales. This work would not be possible without you. And enjoy the artistic rendition of my NMDS plot. Thank you.